reciprocal system of vectors. If A, B, and C are three non-coplanar vectors such that box ABC is not equal to 0, then A dash vector, B dash vector, and C dash vector are known as the reciprocal system of these vectors, that is A, B, C respectively, which means A dash vector is called the reciprocal of A vector, B dash vector is called the reciprocal of B vector, C dash vector is called the reciprocal of C vector. And these reciprocal vectors are given in this way. That is A dash vector is equal to B vector cross C vector by box of A, B, C. Box product is nothing but scalar triple product. Similarly, reciprocal of B vector, that is given as C cross A by box A, B, C. And reciprocal of C vector is given as A cross B by box of A, B, C. Now let's see some properties of these reciprocal vectors. The first property is when you multiply a vector with its reciprocal, you'll always get output as 1. So let's prove this. So let's take LHS as A vector dot reciprocal is nothing but we have just seen that as B cross C by box product of A, B, C. Now A dot B cross C is nothing but scalar triple product, that is it is also a box product. So when you divide it by the box product, you will get it as 1. Similarly, you can prove for B vector with its reciprocal and C vector multiplied with its reciprocal, the output will be 1. Now, second property tells us that when you multiply a vector with its different reciprocal vector, the output you will get it as 0. Let's see, let's take LHS as A vector multiplied with some another reciprocal vector. Let's take it as reciprocal of B vector. When you do that, it will becomes A dot. Reciprocal B vector is nothing but C cross A upon box product. So now we can write this as box of A, C, A. We have seen a property from the scalar triple product, that is when two vectors are parallel, the output will be 0. So similarly, you can prove for other vectors like these. Okay. So next property tells that when you multiply the box product of the actual three vectors with the box product of reciprocal of these three vectors, the output you will get it as 1. Let's see how it is. So write A, B, C as it is. And here reciprocal of A vector can be written as B cross C by its box product. Similarly, here also C cross A upon box product A, B, and C. And here A cross B upon its box product. So when you take box product as common, you will get it as this box product is original. And when you take this common, you will get it as box product ABC whole cube. And inside it is left with B cross C, C cross A, and A cross B. Now, for this, we have solved a question or we have seen a property that this can be written as box A, B, C whole square, right? So, when you multiply with this and divide with this, the answer you will get it as 1. So, this is the required RHS, okay? So these properties, all the three, 1, 2, and 3, can be used in any kind of question. So it's better if you can remember it with the help of proofs.